Okay, so far we have looked at how you can use either the formula mass to jump between grams and moles of a certain substance, or you can use Avogadro's number to jump between moles and particles, either atoms or molecules or formula units. All of that has been just within a single substance, just converting how much of one thing, just restating how much of it you have, whether it's one of those three things. What we're going to look at doing today is we're going to look at not just hopping on rocks to get across our own stream, but we're going to be looking at crossing a whole new bridge to get to another stream by using a balanced equation. Okay, so in other words, I would be able to answer the question, if I have 50 grams of hydrogen and I burn it, how many grams of water will it make? Okay, now, what you're seeing over here on just this one side, this is what we've already done, okay? We've learned that we can jump from particles to moles to grams and back again. What we're going to look at doing today is, if this right here, say, is hydrogen, and I want to get over here to find grams of the water that I would make, what I can do is I can hop to one stone and change it to moles. Then I'm going to go over a big bridge called the mole ratio, which is something you already know about, you just don't know that that's what it's called yet, to find out how many moles of water that would make, and then I can use its formula mass to jump from moles of water to grams of water. Okay? I'm going to put a copy of this up in the Google Classroom so that you can refer to it, and I'll keep it up on the board while we're working some practice stuff. But let me just kind of show you, for instance, how you go about doing this. We've got a problem here. If we have 5 moles of nitrogen reacting with hydrogen, how many moles of NH3, or how many moles of ammonia, will be produced? So we have to do several things here. First and foremost thing we need to do is we need to see if there is a reaction equation, and if there is, we need to check to make sure that it's balanced. Is this equation balanced? I'm saying some head shaking no. Okay, yeah. So first thing we want to do is balance it, so I'm going to do that real quick. I'm starting off with 2 of those, 1 of those, and 3 of those. So I think I need to put a 2 here, 6 of those, and that fixes it, right? Okay, so now I'm going to go back to my problem, and I'm going to see what is it that I'm given. I am given 5 moles of N2. Okay, I want to find how many moles of NH3. So I am trying to get from right here, which is point A, over here to point B. Take a look here. That means I'm going to be starting right here, and I'm going to be trying to end up right here. So how many jumps away from the starting place am I? Just 1 jump, right? I just have to cross the bridge for the mole ratio. So let me show you what the mole ratio is. I'm going to set this up just like any other dimensional analysis. I'm going to take what I start with, which is going to be 5 moles of N2, stick it over 1. Now for this next step is the new step. This is the mole ratio. And the place I go to find the mole ratio is the balanced equation. I am looking to see what the coefficients are in front of those 2 things. So one of those is going to go on the top in the next step, and one is going to go on the bottom in the next step. Now, you already know, bless you, which one's going to go on the bottom. What do we have on the top? Oh. So since we have moles of N2 on top, where does it go in the next step? To the bottom. So on the bottom I'm going to have moles of N2, and on the top I'm going to have moles of NH3. Okay, just like before. This this right here on top tells me what needs to go down here on the bottom. So then I come up and I look at my balanced equation, and I see out beside NH3, there's a 2 there. I see out beside N2, there's a 1 there. When I cancel my units, look what happens. Moles of N2 cancels moles of N2. What am I left with? Moles of NH3. What does the problem want me to find? Moles of NH3. Aha. So, y'all tell me, how many moles of NH3 am I going to make here? 10. 5 times 2. Just like we've been doing. It's just that we're, instead of hopping over one river, we're hopping over 2. Okay. Y'all feel okay about that so far? Any questions? Does it get more complicated? Kind of, but not really too bad. Let me see if I can find one that would be a little bit trickier here. Okay. This looks good. How many moles of carbon dioxide are produced when 88 grams of O2 are reacted with an excess of butane? First thing I need to do is check my equation and see if it's balanced. Is it balanced? I don't think it is. Okay. So let me balance it with the CH&O. CH&O. Carbon's on this side are 4. Hydrogens are 10. Oxygens are 2. Carbons are 1. Hydrogens are 2. Oxygens are 3. All right. So I really hope this is going to be one of those. No, I can already tell right now I'm going to have to double some stuff. Because I'm going to have to put a 5 right there, and that's going to give me an odd number of oxygens, right? So I'm going to have to go ahead and jump to the double it rule. I'm going to go ahead and make that 10. And that's going to give me 2 times that, which gives me 8 of those dudes, 20 of those dudes, 20 of those dudes, and 6 are carbons. So 2 times 4 is 8, so I'm going to put an 8 here. That gives me 16 oxygens plus 10 oxygens for a total of 26. I need to put 13 right here. Okay, can I reduce that? Do 13, 8 then? Nope. Okay. So it's balanced. I'm going to go ahead and get this out of my way now. So now let's see what the problem is asking. What quantity do they give me here? 88 grams of O2. So that's my given. So I'm going to be starting with O2, this dude right here. There's my point A. Reacted, okay, how many moles of CO2? So that's what they want me to find. So CO2 is right here. That's going to be my point B. If you look, I'm starting with grams of the first thing, and I want to find moles of the second thing. So let's go back to my map. So where am I starting at on this side of the river? Grams, okay? Starting right here. That's not helpful. Starting here. And where am I trying to get to? Moles of B, right? So, from my start, how many hops away am I from one point to the other? 2 hops. I got to hop to moles, and then I got to hop over the mole ratio bridge. So I'm going to do that, again, using dimensional analysis, all in one thing. So I start with what they give me, 88 grams of O2, skip it over 1. Now the next thing I need to do is I need to change grams into moles. So to change grams into moles, what do I need to know? Formula mass. So I need to know the formula mass of O2. Now O2, that's going to be pretty easy because oxygen is 15.999. I got 2 of them, so let's do times 2. That's going to be 31.998, is that right? Awfully close to 32 grams per mole. So I'll do 31.998 grams of O2 and 1 mole of O2. I've hopped my first rock. Now I'm going to cross my bridge. So I do one more step here. Moles of O2 is going to go on the bottom. I'm trying to find moles of CO2. It's going to go on the top. Now, how do I know what numbers are going to go here and here? I look at coefficients. I go up to my mole ratio. So in front of CO2, I've got an 8. In front of O2, I've got 13. When I go to cancel my units, this is so cool. Watch. Grams of oxygen, cancels grams of oxygen. Moles of oxygen, cancels moles of oxygen. What's the only unit left? Moles of CO2. What am I trying to find? Moles of CO2. So on this, I'm going to multiply everything on top and divide by everything on the bottom. So in other words, check this out. I'm going to go 88 times 8 divided by 31.998 divided by 13. I'll go ahead and plug that in and let's see what we get. Okay, what do I get? 1.69 and 1.7. Okay. Cool. All right. So 1. I'm going to say 1.69. It doesn't really matter. 1.69. My units are moles CO2. Okay. So same thing we've been doing. We're just adding. Each time we make a hop from rock to rock, we're adding a step in our dimensional analysis then. Okay? Everything we've been doing, it's just we're doing a little more of it. Same stuff. Questions, anyway? Let's try another one. Okay, that goes from 60 grams. All right. Let's do this guy. What's the mass of strontium chloride that reacts with 300 grams of sulfuric acid? Okay, fine. Do we have a balanced equation? Yeah, that would be too easy, right? So let's balance it. Let me see. 2 hydrogens. 2 hydrogens, 2 fluorines. We got 2 fluorines. 1 SR, 1 SR, 1 SO4, 1 SO4. That's balanced. Agreed? Okay. Now, just so we don't confuse ourselves, the whole AQ and the whole S set just means dissolved in water or solids, so I really don't care. I'm just going to get that out of my way. I need that kind of negativity in my life right now. So let's see what the problem's asking us here. What are we given? 300 grams of what? Okay, that's our given. So which one of these uses sulfuric acid? Is that one? Nope. H2SO4 starts with an H, so it's an acid. It has sulfate, so it's sulfuric acid. So that's my point A. That's where I'm starting. Now what does it want me to find? Mass of strontium chloride is going to react with it. So that right there is going to be what they want me to find. So which one of these uses strontium chloride? The first one. Wait, so I can go backwards? I can do 2 things on the same side of the arrow? I guess. It doesn't matter which 2 things. You can go from any of these things to any of these other things, in whichever direction, whenever you're doing this. Okay? So, since I'm going from the mass, now mass is grams, right? Okay? So I'm going to be going from the mass of one to the mass of the other. So I'm starting over here with grams of A, ending up over here with grams of B. So how many hops away am I? 3, right? I'm going to hop from grams of A to moles of A, so I'm going to need to know the mole mass of that. I'm going to hop over with my mole ratio, and then I'm going to go from moles back to grams, so I need to know the mole mass of the other ones too. So there's a little more background information I'm going to need to find to answer this, but we can do it. Let's find what the mole mass is of SrCl2. I've got strontium, and I've got 2 chlorines. I'm going to have my periodic table here. Strontium's on the left. That's 87.62. Chlorine is 35.453. I'll just do 35.45. So 2 times 35.45 is going to be 70.9. So we do 87.62 plus 70.90. What do we got? 158.52. Somebody confirm? Sounds like there's 2 people doing it. Just keep it. Cool. 158.52 grams per mole. And that's for my strontium chloride. I'm going to cheat and do something else can't do, so shrink that down just a little bit. Let's go ahead and do the same with our H2SO4. Okay, so I've got hydrogen times 2, I've got sulfur, and I've got oxygen times 4. Hydrogen is 1.006. Sulfur is like 32.07. And oxygen is 15.99 times 4. So that's going to be 2.012. That's still going to be 32.07. And that's going to be like 63.996. Okay, cool. All right, so we add these 3 up. What do we get? Close to 97, 98. 98.304. Okay, cool. I'm just going to call it 98.30. Okay, grams. Same thing I did a second ago, and cheat and shrink all this mess down. And now I want to shrink this mess down too. Okay, that's good. There we go. And kind of keep it out of my way. I want to be able to have some workspace here. So now we've got all the information we're going to need. We're going to start with what we're given, which is 300 grams H2SO4 over 1. Our first hop, we're going to change grams into moles, so we're going to need stuff from this step right here. So what goes on the bottom? Okay, so how many grams? From my blue. 8.3 grams H2SO4 and 1 mole H2SO4. Okay, so at that point I've got moles of H2SO4. My next step, I'm going to cross my mole ratio bridge. I'm going to use my ratio. Oh, that's nice. One is 1 to 1, right? And I'm not going to have to do that much math, so I'm just doing this for the unit. So 1 mole H2SO4 on the bottom, 1 mole SrCl2 on top. Okay, so then moles will cancel moles. I'll be left with moles of that stuff. My last hop, I'm going to use what I've got in red over here. So what goes on the bottom in my final step? Moles of SrCl2. So 1 mole of SrCl2 goes in here. And mass, 158.52 grams of SrCl2. I'm going to cancel all my units. Grams of H2SO4 cancels grams of H2SO4. Moles of H2SO4 cancels moles of H2SO4. Moles of SrCl2 cancels moles of SrCl2. I am left with grams of SrCl2, which is what they want, right? What we need to find. So, looks like it's going to be 300 times 158.52 divided by 98.3. Multiply all the ones on top, divide by all the ones on bottom. If we had an answer. Okay. Did I hear 383.7? 183.7? 483.78? Okay, cool. So my answer is 483.78 grams of SrCl2. And I'm done. Okay. Now, somebody point out for me, what is a pitfall of working this kind of problem? I mean, what's the most obvious problem with this? Well, so much work to do. Can easily mess up because there's a lot to keep track of, right? So that's going to require a lot of paper. I mean, there's just no two ways about it. You need to have paper to balance your reaction. You need to have paper to find your mole masses. You definitely need to have paper to lay out your DA. Okay? And it takes time too, right? So, key to this is use lots of paper and don't get in a hurry. Another big key to this, label everything. You see how I don't just put numbers? How the units themselves are ridiculously important because they tell me exactly where everything's supposed to go, right? So you gotta write everything out. And I know so many people hate writing stuff out. I get that. I hate writing stuff out too. But it's just necessary thing. Any questions? Okay. So I want to maybe look at one more. Okay. Let's find one that's maybe not that helpful. 10 grams of lithium hydroxide. That's about the same. We can do another one just like that last one if that would be good. 20 grams or 1 gram to the other. Cool, let's do it. Alright, so if you start with 10 grams of lithium hydroxide, how many grams of lithium bromide will be produced? So, is that a balanced reaction? Actually, lithium, lithium. Yeah. OH to OH. Yeah, it's totally balanced. So it's just going to be 1 to 1 to 1 to 1, right? Well, that's nice. Okay. So if I start with 10 grams of lithium hydroxide, that's my given, right? Which one's lithium hydroxide? LiOH. There's point A. I'm trying to get to grams of lithium bromide. That's what they want me to find. So where's lithium bromide? LiBr, good. That's my final point. So I'm going to go from, if I had my little pond here, I'm going from grams to moles, and cross my bridge to moles, and back down to grams, right? So I'm going to need to find the mole mass of lithium bromide. I'm going to need to find the mole mass of lithium hydroxide. Doesn't look like that's going to be that bad this time around. So lithium hydroxide, LiOH, looks like it's going to be 6.941. You know, for our purposes right here, let's do a little bit of rounding. You know, let's not make this any more difficult than it has to be. So if I had to round 6.941 to the nearest whole number, what would you call that? 7. Okay. So lithium is 7. Hydroxide has got an oxygen and the hydrogen. Oxygen is about 16, hydrogen is about 1, so 17 plus 7, 24? Okay. Let's do lithium bromide, same kind of thing. So lithium again is about 7. Bromine is awfully close to 80. So how about let's just call lithium bromide 87 grams per mole for our LiBr. This is for our LiOH. Everybody happy with that? Okay. So y'all tell me. I'll be your pencil. You tell me what you're at. Okay. 10 grams LiOH over 1. Yes, it would. Okay. I don't think I would yet. I have to get from here to here first. Uh-huh. Great. Okay. All right. Okay. Over. Well, I got one more. Yep, yep. 1 grams. Moles. Other moles cancels other moles. I'm left with grams of lithium bromide, which is what I want. Okay. So now what? Okay. So 10 times 87 divided by 24. Somebody confirm? 36.25, okay. What's my units? Good job. All right. Well, folks, I got good news for you. That's as hard as it gets.